Welcome to this introduction session for Docker for beginners. Today's agenda is basically on these are all the topics I would be covering it as part of today's session. Let us start. In order to understand virtualization, so first we need to understand before virtualization, say around roughly 15 to 20 years back, in order to stand a three layer application, if you wanted to host it, obviously it would be when we say it's a three layer, one is a front web layer, application layer, and a database layer would be there, right? So what we used to have is, so during those days, we used to make sure that we used to procure three servers depending on the need of, if it is a front end, little bit low spec database, depending on the database, but to procure this system. So there would be a separate data center, a separate room used to be there. So we used to call as a server room kind of a bit. So all these servers, each servers, for this kind of application, we used to procure minimum three. So in one servers, we used to keep our web layer. We used to install either Apache or a Tomcat server. So in the app layer, we used to deploy our JBoss server or any, those days it was BE, WebLogic, and all those bit used to be there. Those servers we used to run it. And DB, a DB2 or a MySQL database or Oracle database, we used to have it, right? So in before virtualization, this was the case. So during that time, so all these three was three servers, it was never fully utilized, right? So maximum 30% of a CPU or memory we used to utilize it. So thereafter, a concept called as a virtualization came into picture. So before virtualization, we used to believe that one server means only one task it will handle it, and it won't handle more than that. Because of that, we used to keep separate application in separate servers itself. So when virtualization came into picture, so what we did was we tried to reduce our resources because of virtualization. In this example, so we kept a database in a DB layer itself, and if you see what we managed was app layer and web layer. It was consuming barely 30% of it, right? So the another 30% of as either a CPU or memory, those application we shifted to the first box itself, right? First server machine. Because of this, but so what is the immediate gain we got was one of the server was either decommissioned or it was used for different application purpose, right? So immediately we saved that cost, as well as even in order to make it up and running, we need to have a electric power. We used to keep the server room in a certain temperature in order to run these servers, right? And obviously, if there is a power cut and all those bit, we used to run uh, a generator and all those bits. So those are all the cost cutting we did it because of virtualization. So virtualization, after virtualization came into picture of containerization. When you say it as a containerization, it is basically packaging our software. So in the previous case, if you see over here, a web layer or an app layer, right? Or a DB layer. Containerization is nothing but packaging our complete software, right? A code as well as its configuration. It's dependencies basically. So all these things we packaged it, and we created a image basically, and that image is used by a container in order to create those containers, right? So further we try to reduce it basically. So what we did was, in a virtualization, we used to run only two applications. We can say that another 30% we can combine DB layer also. You can think that 90% utilization, right? So only three application max we used to run it. But containerization, when it came into picture, so because of that one, in the virtualization case, max we used to run three application, right? As part of a containerization, we started consuming it whatever, how much it is possible, right? That much. And on top of that one, it is like earlier it was three, now 30 applications we were able to run on a particular virtual machine. So how exactly it has been achieved, right? So earlier it was only three, right, on a one single virtual machine. Now it is 30. So if you see over here, this is the diagram of virtual machine versus containerization. Here, if you see here at the bottom, infrastructure is nothing but a thing that it's a server machine, and on top of that one, there is a host machine. In virtual machine case, we had a host OS, and on top of that one, there is a software called as a hypervisor. We used to run it. On top of that one, we got a benefit from only running on a single virtual single server, but maximum what we got was running a 3 virtual machine on top of a single virtual machine. So in virtualization case, on a single server, we were able to run a 3 virtual machine, but the application was running, and you can consider it app A is running on a first virtual machine, app B and app C, right? So it has its own binaries and libraries as well as dependencies. If you see here, virtual machine was required another guest OS. On a server machine, we had already a host OS, but in virtual machine, we were supposed to install another guest OS. So obviously, when you say as an operating system, right? So you would be a guest in order to run an operating system. Obviously, you would be getting enough memories required, enough all the libraries has to be installed, right? And it is even the boot up time of a virtual machine. It takes minimum, if you restart a normal virtual machine, it will take 1 minute to 2 minutes, right? And it requires its own space as well. So in order to install a OS, you need a sufficient GBs together of a hard disk itself. When compared to Docker, right? So Docker, this is the diagram for Docker. So what Docker did was it removed removed the guest OS bit, and it is running on a limited libraries. Under infrastructure, we have a host OS. On top of a host OS, we have a Docker engine. That is a software, right? So on top of that one, we have these many application. We have each application has its own bins and libraries and its own minimal what is required for this application to run. Respective binaries only installed on the containers. So similarly, on respective container, what it is required, what was the dependency was there, those things only it was installed on a container. So that is the reason if you wanted to restart a container, it is quickly, I mean, it max it will take 1 or 2 seconds, because it need not reboot so many services, and the binaries are very less, very minimal bit. Coming back to the next one. So what is Docker? So it is an open source DevOps tool designed to help developers as well as operations. So in the olden days, what used to have it, that is during virtualization period. So if when developer or a tester, right? Once the developer is tested, right, developer usually has a mentality saying that it is working fine in my laptop, right? When the tester tests the same application in the test environment, so application we used to have a lot of errors, right? So on a particular image, developer will code it, and that particular image has the software, whatever it is required, all the dependencies bunched together in a particular image itself, Docker image. The same Docker image, it was passed on to the operation guy. The operation guy's responsibility is to deploy it to a dev environment, test environment, and further up higher environment, whichever, depending on the company. Usually a test, pre-prod, and production environment, it used to be there. Before virtualization, developer used to give to tell this is my repo, you build it, right? And it has to be deployed on the dev environment and further higher up. But there were used to be if there is an instruction is wrong, the operation guy won't be knowing about what all the instruction it has to be followed, right? Maximum there was a release notes. If a developer forgets to put a particular configuration, then in the higher environment, we used to get a hell lot of errors, right? So this image concept, everything it is bundled, all the configuration is done, it has been tested in same package is moved to the higher environment. So we have removed all the manual errors, and it was easy to build because it doesn't have you need not build it from the scratch. In the virtualization case, you used to build a dev environment, test environment, and further up. But in case of containerization, what happened was you build an image, test it out in the dev environment, and take that particular image into higher environment. So if it is tested, if it is proven in the dev environment, it will work as is. There is no surprises. Coming back to Docker installation, so it is basically a bit easy. So if you go to a Docker website, so if you are on a Windows, basically what you need to do is just download this exe, and if you run it, it should be able to seamlessly install it. So there are a couple of installation hiccup you may face it. So those related, if you click on this, but once you install the exe, just that this is basically an app, right? So if you click on that, you would be able to see this kind of one second, just I'll show you this kind of a dashboard. Basically, this is a Docker dashboard, right? So you would be able to see images, volumes, and containers. It is a straightforward. There is no issue at all installing Docker on your laptop. If you are running on a Mac, it's basically a DMG file. So depending on the Intel chip or Apple chip, it is basically you need to install it, and it is fairly simple. If you drag it on to here, clear up and running, you won't be able to face any particular issue. If you are planning to install on a Linux machine, that is also documentation is pretty good. I had done it manually. It is some 3 steps process. That's it. So you would be able to run it without any hiccup. Okay. So if you face any issues, you can always reach me. This image is nothing but it's a complete package. We build it. You can think it of as a exe of any software. You can't modify it. If you downloaded it, it is sitting in your laptop. It is using a space. That's it. Other than that one, nothing else, right? If you install any exe, any software in exe, then only that particular application you will be able to use it. In the similar concept, Docker image is a complete package which bundles out all the application related dependencies and its configuration. So it is kind of a exe or a zip file. If it is in a zip, you can't do anything. It is a kind of a useless, basically, right? And Docker container, it is nothing but it is a running instance of an image. And Docker image is immutable. Immutable means you can't modify it. It is once it is packaged, you can't modify it. If you wanted to add any new configuration, you need to create a new image, next version, right? So in the container case, once a container is running, you can modify few of the configuration. If you wanted a memory to be increased for that particular image, you can do that. Docker image which can exist without the container. So it is just a kind of a exe, right? So it can exist, but there is no use of that particular image. But in container case, in order to run a container, you need an image. While running the container command itself, you need an image. Without image, container doesn't exist. You cannot run a container without an image. As I said earlier, Docker image is immutable, and once you created it, you can't modify it. Hence, you need to create only once. Coming back to containers, so you using once you create a container, you can with the same particular image, you can create n number of times. So think that you have a web layer which is Apache is running, one container is running of Apache, and there you are expecting a hell lot of a load. So during the load, obviously your one web layer, either Apache or Nginx, it cannot withstand that much of a load performance. So you need minimum 10, right? So with the existing image, what you are using it, you can increase the replica set to withstand that kind of a load. You can create the same with the same image. You can create 10 instance of Apache. Next main difference is compute resource. In order to keep a image, right, you don't require any compute resource. Meaning you don't in that particular virtual machine, you know a CPU or memory, it is not at all utilized. So it is the space is utilized. Other than that one, it is not using a memory or CPU. In case of a container, when you run the container, right, we need compute resources. Basically, you need to mention a CPU and memory, so that think that your application requires a business logic app layer requires around 500 MB of memory, right? So that kind of configuration, depending on your obviously performance testing, you would assign your particular container with that much of amount of memory. Again, it is developer team can give you approximate figure. We call it as a process called as a sizing, basically. So obviously, at the starting of a project, it is basically on an assumption basis, on a calculation basis, we assign particular a container, particular memory and CPU. But based on our performance testing, depending on the sizing requirement, we do a performance testing, and then thereafter we assign respective containers, respective memory and CPU. Okay, so these are the main commands what in Docker we use it. So Docker pull. A Docker pull is used in order to pull a particular image from a repository. A repository can be a public or private. For a training purpose, we use a public repository that is called as a Docker Hub. So Docker Hub is nothing but a place we store all our images. So from there, you try to download the image, and so next command is basically Docker run. So Docker run is basically in order to run a particular container, we use this particular command. Docker ps -a, it is used in order to check how many processes are running in Docker. To check it, basically it will list out all the containers which has been running. So Docker exe. So once a container is running, right, so you would like to log into those containers and check it, right, in order to debug or in order to check the configuration file, what all the things are there in that particular container. You use Docker exe command in order to log into the box, log into that particular container, basically. In some cases, you wanted to stop your container, right? So in those cases, you can use a Docker stop with the container ID. You can stop that particular container. In order to package your application, we need to create one particular image. So that particular image, we use a Docker build command in order to build the image. Once you build it, we need to push that particular image into a private or public registry. So in that case, we use a Docker push command. Docker rm command is used to remove a particular image. You think that once you once you tested any application, and then it is consuming memory and it's consuming space and all, so you wanted to delete it off. So in that case, what we could do use is Docker rm and image name, image reference. You can use that one and you can delete it off a particular image. Let's go to practice session. So prerequisite for this particular practice would be a Docker should be installed. Next commands are basically a Docker container run. If you wanted to run a particular container, how exactly it has to be run, that particular bit. Next command is Docker build to build a particular image, and then thereafter a Docker push command. A sample Docker file, it's a basic Docker file. Content would be from Nginx and copy this particular file. So let us go to a demo bit. Okay, let me show you a Docker hub. Okay, so we said about all our images should reside in a particular place, right? So if you see here, Docker hub is a public repository. Okay, So most of the Docker images. So if you see, if you try to let us take Jenkins, right? So if you see Jenkins, so you can see over here, this particular image is a public image pushed by Jenkins official company, right? So if you could see here, you can check verified publisher or official images. So these are all the public it's a public repository. Jenkins itself has pushed this particular image, Jenkins company. So at least you can be safe in order to uh, trust on this particular images, because it is built by the official authorized company itself. And when you check it, so if you see here, these are all the tags are basically a version of Jenkins image, basically 26.03. This is the version of this is the version basically. So there are many tags are there. If you wanted a specific older version, you can choose that one, right? So how exactly you want in order to in order to use this particular image, there is a command is there. So docker pull Jenkins 2.603. If you copy this and if you run on your laptop, you would be able to download the image. Okay, so let me start with the demo with my application, what I had done it. So in this example, so this is our beginner academy's Nginx basically. So what we had done is we had created the Nginx and we have pushed in Docker Hub registry, and there are basically 1.0. These many versions are there, right? So think that I wanted to install 1.0 now, right? So I wanted to test this bit. Okay, how exactly I would be doing it? Show you. So I'll just copy this basically. So let me open up one terminal. So if you see here, the command wise, I'll try to explain what it is. Docker is a Docker command basically. Next is a container. So what I wanted to run is a container run command, and this is a name I wanted to give it. So here we can put it as this name is whatever we wanted to do it. Give we can give it. It's just for our reference purpose. I will say demo 1. Okay, and D minus D is a detached mode basically. So if you if you are if you have a background about software, detached mode and attached mode is basically whatever I would be running this application, right? This particular command, right? So if I do a control C, then my application itself would be closed basically. It would be exited, that particular application. It will stop running, right? So hence I wanted to run in the background. IT is interactive terminal basically, and minus P is basically this is my 8080 port and 80. So 80 is the host port, and this is my sorry, 80 is a container port. In 80 port, this Nginx would be running it. 8080 is my port. From localhost, I would be able to access it. So before that, this is a beginner academy is the this particular name, and this is the image. Okay, and this is the 1.0 is the version we would be installing it first. Okay, so before that, I'll show you nothing would be running container as ls. So if you see, docker container ls is nothing but I'm listing out is there any containers are running in my laptop. So you could see nothing is there. So next command is basically to check image, docker image list. There are no images are there. Okay, So what I will do is now I will run same command. Okay, so if you see here, okay, so what it does is when I run it, it tries to find this particular image locally on my laptop. If it is unable to find it, then only since it is unable to find this particular image locally, it went to Docker Hub to pull this particular image. So if you see here 1.0 pulling from beginner academy BA-Nginx, right? So if you see here, it has said already exists. So what it did was it could not find locally, hence it went to Docker Hub in order to fetch it. By default, you can mention your own registry bit. In this session, I won't teach you about different registries. It is only about Docker Hub, public one. So in the next session, probably I'll take about private registry. So if you could see here, it is able to pull it from our Nginx. So if I do localhost 8080, so if you see here, this is what it is currently running from my image. Basically, this is a basic. This is a Nginx which is showing it. Okay, so if you check my, let us check the container now. How many containers are running? So if you see here, this is the container it is running. This is the container ID. It would be unique. From image is this one. This is a bundled image. It is immutable. This is the command at the starting. It would be run. So if you see created about a minute ago, status is about a minute ago. So it is a port. This is my local host. It is forwarding it to 80 of a container port. The name what I gave given was if you see it, Nginx, that is the name. It will show it over here. And if you do the same thing, check for images. Yeah, if you would be able to see this particular image, and with the tag of 1.0, it is this is the image. It is downloaded. Okay, before that nothing was there. Okay, so now think that container one container is running, so that is a 1.0. So you have a requirement. I wanted to run second next 1.1 version container, so that I can see. You wanted to test it out 1.1 version as well, right? So as you're doing development, 1.0 is live, 1.1 you wanted to do a testing. So in order to do that particular in order to run those that particular version, remember that you can run n number of containers with a different version as well. So what I would be doing is 1.1. So basically, if you see here, 1.1, this particular image I would be running now on my laptop. Okay, so Docker 1, I'll just mention it as the name demo 2. Since already there is a 80801 something is running already, so I don't want it won't, if I run directly as is, it won't run it because there is a port is already used, right? That is the reason I need to increment the port. So if you see here, 1.1 doesn't exist. If you see here, there is a image already. It checks it whether it is present or in my local directory or not. If it doesn't exist, then only it will try and fetch it. Now demo 2, if you see a container ls, you would be able to see 2 containers are running. One is 1.1 and next one is 1.0. And 1.1 is running on
8081. So if we do a localhost 8081, you would be able to see next version of Beginner Academy. This is the bit I have modified it basically. Okay, so if there is another way of seeing the same thing, that is using a Docker dashboard basically. The same thing, whatever you have seen it via CLI command, you can see it here as well. So this is the first image, BA Nginx, which is running. Second one is this is the container, first container, second container. If you see images, 2 images been downloaded, 1.1 version, 1.0. If we have a volumes and all those bit, that it could have been seen over here. Currently, we are not using volumes. And if you could see remote repositories, I'm using a Beginner Academy repository. That is the reason we are able to see all the versions of this particular Nginx here. Okay, so let us now go to next step, that is to build a Docker file. Okay, so I had already created a Docker file. So remember that Docker file should always be named like this only, Docker file, with the same file name. There should not be any extension. Okay, so let me open it for you. So if you see here, it says from Nginx. So I would be running a Nginx container. My container would be, the base image should be this Nginx. So, and then what I'm doing is copying the index.html from my local, this particular folder, and this is the destination of index.html. Whatever you are able to see it here, right? This HTML, this data, it's basically present in this particular path, in that particular container. So I'm copying from my local machine, local folder to this particular path. So if you see here, so this is the data, currently it is there. So let us modify it. Okay, so let me, okay, emptied it. What is today the date? Welcome to demo session. April 2022. Something I've written, right? It's just a demo. That is the reason I kept it like this. So let me close this. So if you again see the content, this is what it was added. By mistake, I've added this as well. Let it go. I don't mind to be print to be shown in the browser. Okay, so let us build this particular index.html. So what command we would be using is basically Docker build. So we would be using this command. Okay. So Docker build -t, and this is the name we are giving for the image what we are building it. I'll just mention this as a demo, right? And you need to mention from which folder you wanted this image has to be built. So I'll mention dot. Dot means the current folder. In this current folder itself, my index.html resides as well as a Docker file. Hence the dot it has been given. So if you see here, so what it did was it created a BA demo images. Let me show you. Docker. It created the image for us. Okay, so ls. See here. this is the particular image 13 seconds ago it was created, right? So in this way, you create an image for any of the application. This is just an example, just a copying of one file to a Nginx, right? That is what I have done. Okay, so let us, this is a building of a particular image. So now let us tag it. Okay, so if you see here in the Docker images, one point three is the last one. So what I would be doing is I'll be mentioning it as 1.3, 1.4. So in order to run this, couple of things. Currently, what I'm just doing a tagging basically. What I'm tagging is ba.demo. That particular image, I'm adding a new tag for a BA beginner academy BA Nginx 1.4, so that it has to go. It has to be pushed properly. Okay. So remember, BA demo, I need to push it to a Docker Hub registry. So that is the reason I need to copy the image ID of which one I'm currently tagging it. I'm tagging this BA demo with another new tag as a beginner academy with the 1.4 version. So if you do a ls, there is another entry it was added with the tag 1.4. So now it is there in my local. So I wanted it to be pushed it to Docker registry. So what I would be doing is Docker push. This is my in the Docker registry. This is my registry repo my details basically. So what I would be doing is just Docker push and these details. So if you see here, I just started pushing it. Okay, so now Docker has pushed this particular image, the 1.4. So if you see here, 1.3 was running. So let me refresh it. Yep. So if you see here, 1.4 was added few seconds ago. Okay. This is the public repository. Anyone can use it. So now what I will do is, now currently whatever the index.html is running, right? So now our tester wants to run it. So before that, what I will be doing is image ls, right? Docker ps minus a. There are currently these many versions are running. So let me clear out the image so that I can download it from Docker Hub. Think that I'm testing this 1.4 version. So I need to test this the new image. Okay. Yeah. So if you could see Docker image, I don't have a 1.4 version present over here. So let us clear it and let us run the 1.4 version now. I'm a tester. I wanted to test it out a new version of image. So if you see here 1.4, let me rename it as a demo 4. Okay. 8081 8080 and 81 is already used. So let me use 8083 84. So let us 8084. Okay. So if you see here localhost 8084. Yeah. So if you see here the same image
we were able to download it, and that particular container we were able to run it basically. Okay, so let me show the container that is container ls. So if you see here 1.4 also it is running on 8080. This is a container basically. If you see, container id is unique, name, image name, command, and created, and status and port, the name. Okay, so like this there are n number of images are already present in Docker Hub. So basically think that Docker Hub you wanted to do some few testing, right? So testing of a few of the application. Think that you don't know Jenkins. You wanted to test Jenkins, right? You wanted to play around with the Jenkins. With the Docker, you can do it very easily. So what you could do is take which version you wanted to test. So let me take 2.6.0. Okay. So, okay. Any softwares which is readily available, that you would be able to test it out in on your laptop itself. So if many of you guys wanted to become a DevOps engineer, right? In that case, you wanted to, if you don't know Jenkins, right? In that case, what you could do is you wanted to run Jenkins on your laptop, and you wanted to practice it, right? So what you could do is just mention, let me run 8085. It runs on 8080 port, right? So just Jenkins, I'll just name it as a Jenkins. Okay. Docker container run name I'm giving in my as a Jenkins demo 5 det minus D is a detached mode, IT is interactive terminal mode. Okay, 8085 on my local port, it is 8080 container port. Okay, this is the Jenkins official image of from the company Jenkins. Okay, I wanted to run 2.6.0. Okay, so if you see here, what it does is it first tries to find it on my local. It doesn't exist. These are all another thing to notice. These are all the layers basically. So Docker works on a layers basically. So if there is a change in on one particular layer, it will try to download only that particular image. So it would be faster. So let us see. It will take a couple of seconds more in order to deploy it. 1 second. In the meantime, it will download it. So I'll do a self promotion. I have around 18 plus years of IT experience. So I'm currently running my, I'm currently working in Publicis Sapient. So I'm trying to give back to a community. That is the reason I've created this Beginner Academy YouTube channel. If you are interested, you can have a look at it, my content. Okay. So let us see. Yeah. Yeah. Jenkins is downloaded now. So let us see the Jenkins. Let us see the containers. Okay. Docker container ls. So if you see, Jenkins is running, right? It is 42 seconds ago it was running. These are all the ports bit 8085. Let us launch it now. You can check even images ls. It is running over here. I mean, it is downloaded. Image is downloaded. So let us check it. Localhost 8085, right? Yep. So if you see here, you are able to launch Jenkins. So Jenkins, if you're aware, the password, it is kept it over here. So how to access that password, right? So go back to your Docker dashboard. So if you see here, Jenkins is running over here. There are these many commands are there basically in order to check it. So if you click on that, it will show you the logs basically. So if you see this password is over here, copy that, paste it over here and continue. I won't try to install any of the bit. Let me close it and start the Jenkins. So if you see here, now you're logged into a Jenkins. So if you wanted to do few more, when you wanted to learn, do a R&D on Jenkins or any of the MongoDB or any of the softwares, most of the softwares companies has everything on in Docker Hub. You can find those images. So let us create one particular Jenkins job, right? So let us say demo and choose this particular pipeline. Let us create one sample application, sample hello command. Okay. So what I will do is I will just echo it, echo, echo transio training, right? Say welcome to, okay. Just I'm trying to show you how exactly you can test it out. So if you click on that, in Jenkins, you could see this particular job you are created it. So I wanted to run it, right? Yeah, I have run it. So just you wanted to see the console output. If you see here, welcome to, if you see whatever the echo welcome I have written it, it ran it basically. Okay, this is just a demo of a Jenkins basically using container, right? So in this way, what you guys can do is, since you're learning all the new technologies, right? So in the similar fashion in the Docker Hub, let us take any example. So if you search Mongo, right? MongoDB. So this is the official image. You wanted to, if you wanted to practice or trial around on the MongoDB bit, download it, test it out, whatever practice it out, and then destroy that particular image itself. Even Circle CI, whatever the tools, almost there are n number of images are already present in Docker Hub. So using that one, using Docker, you can spin it off that particular container, download that particular image, run the container, and test it out. It would be so easy, right? Okay, the next step is removing the container, right? So basically, I can do it from multiple ways. You can click on dashboard, right? So from here itself, you can stop it, or you can directly delete it off. Okay, let me show it via command better, right? So Docker, okay, let ps minus a, it gives all the list basically. All the images are there. So minus q, it is gives only this particular container ID. So in order to stop your, in order to stop all these containers, you can do it one by one, or if you have a, in my case, there are 3 are there. So all the things, if you wanted to run it, you can loop in this way. It will try to stop all the bit. And then just in order to remove it, if you see Docker, nothing is there. No containers are running. So now if you see image ls, these many images are there, similar fashion. So if you see Docker images minus Q, it is listing it out everything, right? If you see these many images are running, so I wanted to clean it up, right? So RM is used for container deletion. RMI, I stands for the image. Okay, so if you run that bit, it is deleting it off. Okay, it got deleted. So let me do a ls. Nothing is running now. Even the same thing, you could see it over in dashboard as well. Nothing is there. Images is empty, right? So in this way, you can practice it out, right? If you are interested in learning more about multi-cloud and DevOps tools, please subscribe this channel and like this video.